Just to warn you, if you see me grimacing in pain, it's not because you guys are asking me difficult questions. I had a little biking accident this weekend and having a little hard time breathing, but we're going to power through. So I wanted to start off by setting the stage, if you will, around how I think about smarter search. And at the end of the day, I really like this notion of if you remember nothing else from this talk, I want you to think about search as something that allows you to build very fast and efficient ranking engines. And if you think about with all the data that we have, it's ever more important to know what's important. So I like to think about search as a way to help users figure out what's important in their data. And so if we kind of take that from a high level, we can then dig in and we can talk about what I want to spend the time here on with you today is kind of a top-down view of starting with some use cases around where search can be effective for you, and then talk about this thing of Solr and Spark together, and then I'll leave you with a little bit of code you can go check out if you want, a little application you can try out, and then some tips and traps. How many people here actually work on search or have leveraged search before? Okay, so a little bit. So hopefully, for those of you who haven't worked on search, you'll see some things, and I'll give you some food for thought about where and how you could use search in typical data science applications. And if you want to learn more, I've done other talks. Just if you Google my name and data science with Spark and Solr, I think you'll see a lot of interesting things that come along with that. So if you're not familiar with search, I think one of the things that's really evolved over the, say, past 5 years around search is that it's gonna come a long ways from the traditional put in some keywords and get back 10 blue links. You know, you heard Ricardo talk about those 10 blue links, and whoever that engineer was that decided 10 was the number. But these days, it's gotten to the case that a lot of these modern search engines, they handle spatial data very well, they handle numerical data, they do joins, grouping, they do faceting, they do all kinds of really interesting slicing and dicing of the data. And plus, you can give your users a very natural interface to the data. So I think ultimately, search is one of these democratizing technologies when it comes to data. And we see in our company, we see use cases across a large variety of areas and verticals, ranging from working on log data for customer insights all the way through to doing similarity models between chemical compounds, where scientists are actually saying, I want to rank my data based off of the molecules in the compounds that I'm studying. So you see a very large set of use cases. Happy to talk about those in more depth as we go. So the premise of this talk is Solr and Spark. If you're not familiar with those, just some quick list of features around what Solr does and what Spark does, and then we can talk about the joining of the two and maybe talk about some of the ways we can do machine learning with those things. So again, at the end of the day, if you haven't looked at search, I think when you look at this list, you're going to be like, wow, that's well beyond what I thought a search engine could do. Perhaps you've heard of something like Lucene, and maybe you're a little bit familiar with that. Perhaps you've heard of Elasticsearch. Solr is part of that same Lucene community. It's been around since, I think, 2006. You know, at its core, obviously, it still does full text search, right? Keywords, 10 blue links, all of that kind of stuff. But for instance, most people these days would be really surprised to know that Solr does SQL. You can do full-on SQL joins. You can do aggregations, group by, sorting, all of the things that you're traditionally used to seeing out of a database or out of something like Drill or Impala and those kinds of things. Other things that made Solr kind of well-known to begin with, faceting. Maybe you're not used to the name faceting, but you inherently know what this is. You go on Amazon, you type in TVs for your search, that side nav where it says, you know, there's 27 Sonys, 15 Samsungs, all the way down the list. Other things that are, I think, pretty interesting, we deal with users typically don't know how to specify what they're interested in, so things like spelling, autocomplete, hit highlighting, all of these things designed to help users discover what is in their data. And at the end of the day, I think that's one of the really powerful things about search is that it not only enables people to find what they're looking for when they know what they're looking for, but you can actually use all of the data you have in your search engine to help them discover other things as well. Some of the other kinds of things out of the box that perhaps you're doing using other techniques, things like deduplication, graph traversals, doing grouping and joins. There's actually a lot of stats capability, language detection. All of those things are built in out of the box. And oh, by the way, all this stuff scales very, very well. I think last reported, Bloomberg, for instance, has upwards of 300 billion documents in their Solr index. Salesforce is in the same realm, and there's lots and lots of other companies that scale this quite nicely. So you know you can go from playing around on a single node all the way up to thousands and thousands of nodes. On the Spark side, based off of the questions earlier, it sounds like most of you are familiar with this already, but essentially this is what gives you your distributed compute capability. Very, very fast, lots of nice bindings. Interestingly enough, you can run it in a lot of different ways. We personally run it in standalone mode, but works in a number of other cases as well. Probably the most interesting thing when you start to think about search is this second to last bullet here around the tools for graph processing, machine learning, et cetera. These are often the tools that you need for the offline analysis of your content. So, part of the premise here is let's make Spark and Solr work together. What are some interesting things that we can do with that? For starters, you get the Spark shell for free in there, and we can start to leverage things like building out our indexes in parallel. A lot of people don't realize with Hadoop that it actually started as part of the Lucene project. If anybody's familiar with the Nutch web crawler, that was part of the Lucene project way back when, and it was designed to go out and do web scale crawling and search. So Doug Cutting, Mike Caffarello, they read the Google MapReduce paper, said, hey, why don't we go implement this for this Nutch crawler, right? And so then you could use MapReduce to go and build your indexes out in parallel. Well, Spark is that on steroids, so you can build out your indexes at scale very, very fast. Beyond that, though, it gives you a lot of interesting iterative computations. I started the Mahout project. Mahout was originally built around doing machine learning with MapReduce, and one of the things we very quickly realized is these iterative algorithms on Hadoop are just so slow, right? Now, of course, they're tractable finally because you can at least do them in parallel, but they were still too slow, and so when Spark came along, a lot of the Mahout community jumped on board with that and has been working on porting all of our MapReduce stuff over to Spark. Other things that are of course interesting, being able to do whole corpus analytics. When you look at a lot of the modern web search giant capabilities, that offline task of looking at all of the content, or at least a good chunk of the content, is a really key aspect in making sure you're understanding what your users are doing with it. And then last but not least, being able to join this with lots of other systems, HDFS, Cassandra, et cetera. So we now have a system where we can bring together perhaps our authoritative stores very effectively with our search indexes, or if your search index is your authoritative store, you might be able to sync it up very efficiently with your HDFS system where you're keeping all of your logs, so on and so forth. Perhaps something you haven't thought about as much, since most of you are familiar with Spark, perhaps you haven't thought about the Solr side. And by the way, I'm just talking about Solr standalone with Spark. There's some very interesting capabilities that you get by integrating these two. First off, that whole ranking problem that we talked about, right? The search engine is fundamentally really powerful when it comes to doing ranking and kind of saying, here's a fuzzy sort of all of this data, bringing in a lot of different attributes, as opposed to traditional databases, which are much more geared towards sorting on a specific column. The second item here, though, I think is one of the things that is often underestimated when it comes to building out these applications is you can massively simplify your operations by going just Solr and Spark together, right? One distributed system is hard enough. Two in sync is significantly more complex than each of the ones individually. Solar's been around for a long time, scales very well, very proven out, very reliable. I like to say it gets you your weekends back. Now, as data scientists, we don't always think about those things, but trust me, your DevOps will appreciate you when they know you are giving them a system that is going to stand up overnight and over the weekends and all of that kind of thing. The third item up here, and I feel bad, I always want to go talk to this side of the room too. I've got a bias, I guess, to this side of the room. One of the interesting things when you look at like a lot of the Spark machine learning stuff is a lot of the built-in ways of handling text are just this fourth line here, tokens equals string to lowercase dot split on white space. Anybody who's ever really worked on text knows that's an incredibly naive way of dealing with language. One of the things that we did as a company was to take all of the Lucene analyzers, which have been around for a long, long time. They deal with all kinds of languages. They do tokenization, they do stemming, they do a lot of the feature selection work that you need when dealing with text. Those all now can run in your Spark ML pipelines. And so you can set up all of that stuff, configure it, and just run it in Spark so you don't have to deal with just simple white space tokenization anymore. Trust me, that's a big deal when it comes to getting quality results out of your text analysis. Last but not least, I think this is really interesting, is Solr provides you a non-dumb distributed resilient storage. And what do I mean by non-dumb, right? It allows you to create very interesting types of queries, phrase queries, wildcard queries, all kinds of things that then can be applied and give a ranking across your data, as opposed to those kind of traditional, hey, I'm just going to go iterate through all of the data that I have and kind of roll up off of some sorting column. So you get this random access, right? So if you think about HDFS, for instance, it's always block storage, that kind of stuff. Well, random access into HDFS doesn't exist, right? So if you overlay a search index onto that stuff, now all of a sudden you can query into your data in ways that are much more expensive in other approaches. We still do all right at table scans too, by the way. That SQL stuff that I talked about, that supports streaming and table scans and is very, very fast and efficient. Last but not least, or these last few here, very advanced filtering capabilities. Again, you can filter by all of these advanced queries as well. So, and a lot of times in our jobs as data engineers or data scientists, it's all about reducing down the size of data that we want to work with so we can see what's going on with it and then expand back out from there. Search engine gives you a lot of those capabilities. I've even seen people who use search queries to build out their training and test models and stuff like that because you're keeping all of that in your search engine. Last few things, it's schemaless when you want, i.e. when you're getting started with a data set. One of my favorite things to do when I get a new data set is just to throw it at Solr and say, hey, what does this data look like? And I can start querying it, I can facet on it, and now I get an idea of what my schema looks like. And then as I get closer to production, I say, okay, here's my schema, and then I get all of the type safety and all of that kind of stuff that you want in production. Last but not least, there's a lot of good alternative views of data in there. Spatial capabilities are very significant. You can do polygon intersections. You can find me all of the content along a line. You can do advanced polygons where you have, like, for instance, holes in them, hole in a polygon, other kinds of things like that. There's good columnar store, and you, at the end of the day, have a sparse matrix available to you. So if you start to think about certain operations that benefit from that, you can take advantage of those. What does it look like to actually talk between Spark and Solr? First few lines here, basically just some setup. Solr has a notion of collections. This is a logical grouping of your content. Might be all your logs, might be all your tweets, might be all your financial data. That's up to you to decide and give it a name. And then you just connect to it like you would any other source in Spark. And here I'm getting a SQL context, I'm reading from it, I'm telling it it's Solr, and then I'm loading it, and now I have a data frame. and all your data frame operations are available to you underneath the hood. The Spark Solr integration is going to do the right thing in terms of query planning, all of that good stuff. And then the second item here is just, essentially word count, basically saying how many values are there in this type, in the type field, which is a column on your documents, right? If you want to learn more, there's a URL. It's just our GitHub and then Spark Solr. It's Apache license, publicly available. Go nuts with it. For us, we then feed this into our overall application. I'm not going to spend too much time on it other than, when it comes to Fusion, this is our commercial product that we build on top of it. We primarily use Solr for pretty much everything we do in terms of storage and retrieval. We keep our machine learning models in Solr because we know how to scale it. We can treat it as a blob store. We know how to do the right thing with it. We use it as a key value store in a lot of places, so on and so forth. We then use Spark to, for instance, drive a lot of our log analytics. So for instance, we capture all of our own logs back into a different collection in Solr, all of our query logs, all of our system metrics, et cetera. And then Spark runs, we have a lot of out-of-the-box jobs already set up to do things like build clickstream models or do, hourly or daily roll-ups of all of your metrics and aggregations and all of that kind of stuff. And so Spark, again, is kind of that background crank that is saying, I'm going to go figure out what's my best view of this data. And so we try to automate that as much as possible. Zookeeper, like I said, that's a part of ships with Solr. At the end of the day, that's something your operations people will appreciate. You as data scientists don't need to worry about it too much. But regardless, that's the thing that kind of gives you consistency in your data, so on and so forth. Some of the other things, kind of shifting gears into the machine learning side of things. At the end, I'm going to give you a link where you can actually go try a public repository. We take a whole bunch of data news groups, et cetera, index them in, make them available via Solr and Spark, and then you can actually try out some machine learning on this data set. Some of the things that we leverage out of the box when it comes to machine learning, first and foremost, one of the things you need to be able to do is very easily capture all of that user feedback that you're getting, right? I think when I think about why enterprise search, i.e. non-internet search, fails, it's often because it fails to account for the way users are interacting with the data. And now, most people's first reaction to that is, oh, well, there's not enough users in the enterprise. And while that's true for perhaps small and medium businesses, it's not true in the sense that there are a lot of interactions that happen behind the firewall that companies do not take advantage of, right? So for instance, we worked with one large aerospace provider where they actually were taking in all of the emails, all of the chats, all of those kinds of things, and using the data that the employees were creating themselves to then define an expert network so that you could go into their search system and say, hey, find me the expert on Spark. And it was based on, partially on their own declared interests, their resumes, but also built off of the conversations that those people were having with each other and doing language analysis to say, oh, that person is who everybody talks to about Lucene. He's the Lucene expert, or she's the Spark expert because everybody asks her about the Spark application that they're running, right? And so they're able to then more effectively find talent within their own organization, right? Other places, for instance, being able to, we're working with a large bank where they're taking and logging and making searchable all of the rooms that people go in and out of within the company. You know how you have to use your little key card to get in and out of specific rooms. They're taking and logging all of that into a search engine. They use it for fraud detection and bad behavior, but they also use it to try to identify what resources to allocate, where do they need more space, all of those kinds of things. So number one, thinking about that up front, how am I going to capture that information? Two, we leverage a lot Spark ML, and Mahout comes with an alternating least squares implementation that's good for collaborative filtering style capabilities. We ship all of those out of the box. We ship with a number of clickstream models and multimodal recommenders. I see a lot of people building recommendation engines. They have search being built over here, and they have recommenders being built over here. Well, in my world, those are two sides of the same coin, right? And from what I've seen, these multimodal recommenders are much more effective. So they're much more effective than one or the other by themselves. And yet, companies routinely, they have their data scientists over here doing recommenders, and they have their search team over here. And those two never talk, and yet they're very closely related. So we've seen quite successfully a number of times where if you take and build recommenders out on top of your search engine, you, one, get a much more simple operational footprint, but you also can take advantage of all of the things that search gives you as well. So search helps you overcome the cold start problem, for instance, helps you bring in things like your ranking factors, all of that kind of stuff. I wish I could claim that I invented this, but if you go Google, there's a lot of companies out there that are doing this as well. So other things that are perhaps interesting to people, built-in multi-arm banded experimentation framework, being able to capture what people are doing in different experiments, thinking about trying to train your business analysts, your people who are responding, your marketing team, being able to train them to think about running experiments as opposed to hard-coding rules. That can be a really powerful thing, giving them a framework that allows them to capture those signals and then feed that back into the results. Last but not least, we have a lot of nice support for time series partitions. So if you have time series data, that can be really helpful as well. Getting into tips and traps, it's funny, and I probably don't need to tell this audience this as much, but I think we all are enamored with the machine learning aspects of all this stuff, and I can tell you just in my own engineering team, if I ever say, hey, who wants to work on the machine learning stuff in open source or in the product, et cetera, everybody's hand goes up, right? But what they often don't realize is there's a lot of just what I would call, to put it nicely, grunt work that goes into that. We call it things like pre-processing, feature selection, sampling, all of that kind of stuff. And so I always kind of go back to first order principles and say, start simple, right? You'd be amazed at the effectiveness of some very simple things when it comes to deploying and building out real search applications that just kind of work for the large majority of people, and they don't require anything advanced other than some good engineering practices. So for instance, often adding auto-suggest to your search results, you'd be surprised how many companies don't have type-ahead auto-suggest on their site. That alone is usually a huge win, and it's not as hard a problem as, say, in figuring out how to get some incrementally better NLP algorithm to process all of your queries. And so, again, before you want to leap to all this advanced stuff, sometimes you just need to start more simply there. Next up, I try to get people to think more holistically about what relevance means. Again, so if you haven't worked on search before, this is all about this ranking function, and I want to, when we go in and talk with a lot of our customers and we talk to them about relevance, almost all of them are focused on content, right? What am I putting into the engine, and then what query am I going to run against that? And that's all they think about, right? And especially as engineers, they're like, okay, it's good enough. They don't think about relevance necessarily out of the box. Well, they don't think about it until their boss comes and says, hey, why does relevance suck? Right? And then all of a sudden, they've got a lot of work to do to catch up. So I try to, when I talk with companies, I try to get them to start thinking about relevance from day one. And I know it's a little catchy, perhaps, but when I think about relevance, I tend to think about the 3 C's. Obviously, content here is still very important. What you put into the engine, garbage in, garbage out, still very much applies. These engines these days are very good at handling this side of the equation. Lucene, for instance, which powers Solr, ships with what most academics would say are the best-in-class ranking algorithms out of the box. You can actually change them if you want. But the second one, collaboration, this is really that signal stuff. Start to think about right from day one, how do I capture user feedback, right? Whether that's what they're clicking on or tweeting, sharing, or the fact that they're emailing this article to somebody in the back end of the outside of your application. All of those collaboration events you can keep and track and then leverage to better understand what's going on. Last but not least, context. I think Ricardo mentioned this earlier in his talk as well. Thinking about who people are, where are they, what are they doing? Is this your CEO who's searching versus, your DevOps engineer? All of those kinds of things can feed into making for a better search. In some ways, this is personalization, if you will. And again, as you're doing that, think about how much you want to leverage any one of these. So I kind of think about it as I've got, at least 3 different levers here that I can then apply to say, here's what matters in my application. Whereas, like I said, most people, I think, just think about the content side of it, right? Because that's what they have the most control over, right? Because, users are messy, and who wants to deal with messy users? And dealing with time and space and location and all of that kind of stuff is also messy. So we tend to fall back to what we're good at. Other common traps, I don't know how we're doing on time here, but other common traps that I see across a lot of search applications, and these aren't necessarily just machine learning based, but tend to play out for people. First and foremost, there's a lot of crappy UIs out there. So spend some time on user experience, thinking about how users are interacting with your data. It's often the case that we build search interfaces that are modeled after what Google or Yahoo or Bing or whatever does, a kind of general consumer. But it may in fact be the case that you have a very expert user. And so an expert user may want a lot more capabilities. These engines do a lot of good things. And so if you're not exposing that to them, then you're shortchanging them on the types of information they can interact with. The flip side is also true. You often see very complex search interfaces being marketed to the general consumer, and that's just not ever going to be a happy thing when it comes to finding your data. Despite all of this fancy machine learning we have out there, right, most people with their search applications still have lots and lots of hand-tuned rules. So this is where you guys as data scientists can help really solve this problem. You can often just go in and very quickly learn all of their existing rules. And so then you can say, all right, let's get rid of all those rules. They've already been learned and they're in the system because we're bootstrapping off of your logs. And then we can think about how are we going to give you a mechanism for doing rules correctly. Almost all search applications, you still do have a place and a need for specific rules for a specific amount of time doing a very specific task. E-commerce, I'm running a sale for this week. I need to make sure that widget A is at the top of my results because I really want to move that item, right? Because for whatever reason, your buyer ended up buying 10,000 units when they only meant to buy 1,000 units. So somebody made an error there. So keeping going down, a lot of times, some of these other ones are interesting as well. Second is the first loser. I think we often, maybe human bias built in here, but we often get trapped in that, this result needs to be number one. That's usually not the case in most applications. As long as it's in the first few, you're usually pretty good, give or take, although the web and certain applications, that may not be the case. It's often the case that we as engineers and data scientists end up in some local minimum, right? I once was building a cross-language query engine where I was going between English and Japanese, and I knew exactly one word in Japanese. Guess what? That was the query that I did every single time I wanted to test the system as an engineer. And so it's very easy in those kinds of situations to build in that bias and get trapped in that minimum. So you want to be careful of those things. The flip side of that is also that as you as an engineer, if you make sure you're capturing all that information, when your boss comes to you and is mad about the performance of some particular query, you can say, hey boss, that's nice. I understand that query is important to you, but guess what? It only occurs in 0.1% of all of our logs. Do you want me to fix that one? or do you want me to fix the ones that actually make our money, right? So you want to make sure you capture those things out of the box. The pet peeve queries, that's kind of similar to the Japan query that I was just talking about. Oprah effect, this is the story that, as the story goes, I don't even know if it might be urban myth at this point, but as the story goes, somebody made some big change to their website, and they were running this whole big experiment, and traffic went way up on their website, and they were all congratulating themselves on how smart they were. Well, it turns out that that day, Oprah had said, hey, go check out this website or this book, and that was what was driving all of the traffic. So just make sure you know you're checking your biases in terms of how smart you are as well. And then last but not least, I think, obviously we all make a lot of assumptions in what we do. And so, that's where I see a lot of people end up in traps when it comes to thinking about search and machine learning. So net takeaway, if I could only do 3 things when I'm tuning somebody's search application. First, I always tell them, make sure you're setting up a way to measure your results. You'd be surprised at how many very sophisticated companies out there where you would look at them and you say, those guys are at the top of what they're doing, especially in e-commerce, and they have very little built-in measurement capabilities in terms of understanding what's working and what's not. A freebie usually in search is just handling phrases better. Anytime a user types more than one keyword, they probably mean a phrase, and so treat it as such, even if they don't put the little quotes around it. Last but not least, pretty straightforward and easy to build a simple clickstream model that usually does pretty well with search as well. Again, your mileage may vary here. So if all of that sounds interesting to you, what we've been doing lately, one of the things I've been working on, as well as a few other people on my team, is kind of, I like to call it 20 news groups on steroids. So if you all remember the alt, news groups from way back when, and that was kind of the classic classification problem out there, using the alt news groups from way back when. We've put together a little data set that takes something, I think right now we have 100 different data sources in it. It's primarily from Apache projects, so, Hadoop mailing lists, websites, tweets, etc. Make it really easy to set up and run and capture all of that data, put it into your search engine, and then you've got Spark and Solr together. And so now you can start to explore this data very quickly and very easily. And then we've also just have some examples in Scala that bring together doing things with Spark ML like LDA and K-means and word2vec, and it also shows you how to do that Lucene tokenization stuff that I was talking about. It's all open source. It builds on top of the Fusion platform. So if you're interested in that, go check it out. This is also something we will be putting up as a production site. It even has instrumented on the client. It comes with a client application that has all of that signal capture stuff built in. So it'll capture like time on page, it'll capture clicks, etc. And so it shows you an example of kind of a round trip of a search application. So with that, I've got some time for questions. There's a few links for you.
So thank you very much, Grant, for the amazing talk. Thank you.
So is ANSI SQL supported on Solr?
Is ANSI SQL supported? I don't think it's fully SQL compliant just yet. I know that, this is relatively newly released. It covers most cases. I know people have hooked it into things like Tableau and all of that, and the large majority of things they've tried have worked. The cool thing is how typically when you do select star from where like equals and all you have are percent for wildcard and asterisk for wildcard, you can actually put in full-on queries there, I believe. I'm not the expert on it, but that's my understanding of it. So now you get SQL results ranked by the search engine.
Okay.
Thanks. And my second question is, for the geospatial, is Solr completely capable to provide geospatial insights?
Is it a full-on GIS solution? No.
Pretty much like Esri.
No, it's not a full GIS solution. It's just really good at spatial search kinds of applications. Things like find me all the content in this spatial area, right? And notice I'm saying spatial, not geospatial, right? It's not just geospatial. You can actually do n-dimensional operations, right? So it doesn't have to just be lat long. In fact, some people use it to model, for instance, office hours or when a store is open, right? You can model those kinds of, there's a lot of interesting use cases for it beyond just lat long search.
So we haven't used Solr in a couple of years. We switched over to Elastic for the user-facing search, but I've been taking a second look recently because it looks like Solr is actually much closer to the Hadoop ecosystem. And one thing that we do in our Spark jobs is we do really large, expensive trigram queries. We're doing large-scale text similarity, big pairwise runs across a large volume of long-form text. You throw 1,000 quote queries where each quote's 10, or 20 words at an index, it takes forever.
Yep.
So have you guys worked at all with, say, having the index inside of HDFS so you can have really good locality and have it distributed across your compute nodes so that you don't, say, denial of service your cluster when you have 50 EMR nodes and 10 search cluster nodes?
Yeah, so Solr out of the box can be stored in HDFS. That being said, actually, HDFS isn't that efficient for storing your search index. What we've done with our Spark Solr integration is if you set those up, it can take advantage of data locality. Or if you put your Spark workers right next to your Solr workers, they'll be a lot faster than if they have to go out across. So tends to be if people who are already using HDFS, if they want to store their indexes in HDFS, that's fine, but we don't typically recommend it because the way that the index works with the block cache or with the way blocks are in HDFS, those you have to do a lot of tuning of what's called the block cache, and that can take you a while there. So it really depends on the use case. So, but for yours, I would probably do a lot of that. I would probably try out the Spark Solr stuff. It's still going to be expensive, but it has gotten a lot better. Yeah, especially you might check out the SQL stuff because that's a whole different approach to how we get results out. It's a kind of a streaming thing. So, yep.
James, so how do you compare the Mahout ALS versus the MLlib ALS? And two, is Spark Solr available outside of the Fusion product, like all the clickstream models? Can I use it outside of the Fusion
So the first question was, how does Mahout compare with MLlib?
MLlib ALS, yeah.
Yeah. And I'm not as involved in Mahout these days, but there's some overlap. Mahout implements some algorithms that MLlib doesn't, and vice versa. The Mahout stuff actually has some REPL capabilities around helping you write out all your matrix operations, and then behind the scenes it'll go in and optimize those for you. So it has some query, some planning and optimization capabilities there. For the most part, Mahout's ported most things to Spark. What we're doing is we pick and choose which ones we want to leverage. So for instance, that ALS stuff, I don't believe Spark has an ALS. Maybe they do. So, I don't know how they compare. We haven't done a fine-grained analysis there. Your second question, the Spark Solr integration, that's all open source Apache license. The things like the out-of-the-box clickstream models and all of that stuff, those are things that we build on. In a lot of ways, what we try to do with our product is just ask more interesting questions of the data that's stored in the open source thing. So a lot of companies don't have data scientists on staff. We try to give them a good reference implementation that works for most people in most situations. But then, like this room, you would take and go customize it all day long because you know what you're doing. Other people, maybe not so much.
One more question?
Great.
Yes.
Thank you for the informative talk. Just one quick question about Solr. Does Solr provide a mechanism for A/B testing and also for relevance tracking over time to see how you're doing, how your search is performing?
Oh, she ran away from you. Solr itself does not have that built in. We do have that on top of it. We actually capture all of the data back into Solr, right? Because it's all just log data and you can track your session codes and all of that stuff. And then, we do the variance and all that outside of Solr upstream and what we call our pipelines. So, no, you would have to build it in. A lot of people will use, A/B testing tools that, they've already bought anyways from marketing. So, yeah. All right, great. Thank you for your time.
Thank you very
Enjoy
much,
the day.
Grant. I have 2 housekeeping.